Hello everybody, this video is going to cover our 3.1 notes, which are introductions to triangles. There's going to be quite a bit of information in this first video, but all of it's very important and it will help with the foundation for the rest of this unit, which is going to focus primarily on proving triangles being congruent to each other. So what we're going to talk about today are the different types of triangles that you're going to see. And when we classify triangles, we classify them with two names based on their sides and then based on their angles. Think of it like a first name and a last name. So the first way that we can classify triangles is by the value of their sides. And we have three options. We either have a scalene, an isosceles, or an equilateral triangle. So when I look at a scalene triangle is going to have sides of non-equal length. So whatever side this is will not be the same as this side, which will not be the same as this side. So all three sides are going to be different lengths. When I look at an isosceles triangle, instead of having all three sides of different lengths, two sides will have the same length and then one side will be different. So it's going to look something like this, where the left and the right side of that triangle are going to be the same value, and then the bottom portion of my triangle will be something different. And then an equilateral triangle is a triangle where all three sides are the same length. So those are our three options, okay? We either have a scalene, an isosceles, or an equilateral triangle. Scalene is one of the most common triangles we'll see, followed by isosceles, followed by equilateral. The second way that we would classify a triangle is by its angles. So when you have an acute triangle, that means that one of your angles is less than, not one of your angles, all of your angles are going to be less than 90 degrees. So for example, we could have a 30, we could have a 60, and then, no, let's do a 70, and then this one would be 80. Hopefully that makes 180, yep. So this would be considered an acute triangle. All of those angles are less than 90. An obtuse triangle is where we're going to have one angle that's going to be greater than 90. So for example, this could be 100, this could be 20, and then this could be 60. All of our angles still have to add to give us 180 degrees, but we have that one angle right here that is bigger than 90, and then all three of these angles over here are going to be less than 90. A right triangle has one of our angles being exactly equal to 90. So this angle would be 90 degrees, and then you could have something like, I don't know, that's 120, so this would be 60 left over. And then the last one we have is an equiangular triangle, and an equiangular triangle is where all three of our angles are going to be 60 degrees because they have to be the same. So those are our three options with our triangles. So when I classify a triangle, I would say this triangle is a right scalene or an acute isosceles or something along those lines. So whenever I ask you to classify, I expect a name based on their sides as well as a name based on their angles, okay? All right, let's look at isosceles triangles. So when you have an isosceles triangle, we had already talked about two sides that are the same. The two sides that are the same are going to be considered our legs, and then the side that is not the same is going to be considered our base. So if you look at this isosceles triangle that I have drawn for you over here, we would consider the legs as CA and CB. And then our base is going to be the side that is not the same, which in this case is AB. Your base angles are always going to be the angles that are attached to your base. They're also going to be the angles that are across from those equal sides. So our base angles will be angle A and angle B, and then our vertex angle is going to be the angle that is where our two congruent sides come together, and so that would be angle C. We have this word problem here. It says one angle of a triangle is 5 more than the smallest. So I'm going to go ahead and draw us a triangle, because visualizing this is always going to make it a lot easier. One angle of a triangle is 5 more than the smallest. The third angle of the triangle is 3 times the smallest. Find the angles of the triangle and classify the triangle. So when I read this, I know that we have one angle is 5 more than the smallest. So this is going to be 5 plus something. We don't know what the smallest is, so we're going to say that the smallest will be noted by the letter X. It says the third angle of the triangle is 3 times the smallest. So 3 times the smallest would be 3 times x. So when I plug these things into my triangle, we've got 5 plus x and then 3 times x, but you have to have 3 angles in a triangle. So the other angle that I am missing is the smallest angle, which we already said was x. So remember that we're going to classify the smallest with the letter x. And so I have to make sure that when I plug everything into my triangle that I include the smallest as well as the other two sides. Okay, we know by this point that all three angles of a triangle should add to give us 180 degrees. So I'm going to go ahead and just add those three angles together. X, that's my top angle, plus 5 plus X, that's the left angle, plus 3X, that's the right angle, and those should add to give us 180 degrees. And then I'm just going to solve this algebra equation, 3, 4, 5. So we've got 5X plus 5 equals 180. I'm going to subtract 5 on both sides. I have 5X equals 175. And then I don't know where my calculator is, so give me a second. 175 divided by 5 gets me 35. So X is going to equal 35. Well, remember that X is my smallest angle. So it doesn't really matter how you write these angles down, but one of them will be 35 degrees. When I plug in X over here, that's going to be 35 plus 5, which is 40. And then when I plug in 35 here, I've got to do 35 times 3, which is 105. So I have found the angles of my triangle, and now I need to classify my triangle. So I know the angles of my triangle. I don't necessarily know the sides of my triangle. But if you look at all three angles, notice that all three angles are different. If all of your angles are different, that also means that all of your sides will be different. So we definitely have a scalene triangle because all of my sides are different. And then notice here, I have an angle of 105, which is greater than 90. So I definitely have an obtuse triangle. So when I classify my triangle, this will be classified as a scalene obtuse. Scalene obtuse. And I don't care if you do obtuse scalene, it just whatever sounds better to you. I think scalene obtuse sounds better. And then there are my three angles. Now you can always check your work by adding your angles together to make sure that they add up to 180 degrees. I'm not gonna do that, I'm gonna risk it. But hopefully I got that correct, doing the math while being recorded, because I don't know, it's weird. All right. Going down to number 2, the angles of a triangle are in a 6, 7, 11 ratio. Find the measures of the angles of the triangle and classify the triangle. So just like with the problem before it, I'm going to go ahead and draw my triangle. If my triangle angles are in a 6, 7, 11 ratio, that means that whatever x is or whatever our unknown is, like let's say that x was 2, then one side would be 12, one side would be 14, and one side would be 22, because whatever your ratio is, it's your sides with the same multiplier. So anytime that you see ratio, all we have to do is stick an x with all of those, and those become our angles. So 6x, 7x, 11x. And then again, these three angles add up to equal 180, so I'm going to go ahead and add those together. I'm going to use my calculator because I want to make sure I don't make a mistake. So 6 plus 7 plus 11 equals 24. And then I'm going to divide both sides by 24. Whoopsies. And I get 7.5. So that's a little bit funky, but that's okay. Now, x itself is not an angle. X is what I am going to be multiplying each of my angles by. So I have 6 times 7.5. So one of my angles will be 45 degrees. And then I'm going to do 7 times 7.5. And that is going to be 52.5 degrees. And you can have decimals as angles. That's okay. 11 times 7.5 gets me 82.5. And again, if you're unsure, I would definitely go ahead and try to add those three angles together to make sure that they add up to 180. Okay, again, I need to classify my triangle. So let's talk about the angles first because I have those. So if you look at all of your angles are different. So we know we have a scalene triangle, but then all of our angles are also less than 90, which means that we also have an acute triangle. So this is going to be a scalene acute or an acute scalene. It doesn't matter. I'm just going to say scalene acute. I don't think that sounds as good as scalene obtuse, but I think acute scalene would sound better, but whatever, okay? So again, I'm classifying it by the sides and the angles. All right, next we're gonna talk about remote interior angles. So whenever you look at a, or really any polygon, you're going to have an interior and an exterior angle next to each other. So if you look at this triangle, for example, you can see that angle 1 is an exterior and angle 2 is an interior, okay? And they're gonna be next to each other. And I can extend any of my lines of my triangles in order to have an exterior with an interior. So it says the exterior angle of a polygon is blank and blank to an interior angle of the polygon. So when we look at our exterior angles, okay, exterior angles are always going to be adjacent to an interior angle and supplementary to an interior angle. So if I look at this example here, my exterior angle is angle 1, my adjacent interior angle is angle 2, because these two angles are next to each other. So then what we have to do is we have to talk about the remote interior angles. Your remote interior angles are just the other two angles that you happen to have inside of your triangle. They are the angles that are not adjacent to the exterior angle. And what's really cool is we can actually find the value of our exterior angle if we know the remote interior angle. So if we know those purple angles, we can find the exterior angle. The exterior angle of a triangle is equal to the sum, which means addition, the sum of our remote interior angles. So what do I mean by that? I mean that angle 4 plus angle 3 added together is going to equal the value of angle 1. So here's an example. I have my exterior angle. Notice that the adjacent interior angle is not available. So I know that my two remote interior angles should be able to be added together, and that is going to equal the value of the exterior angle. I'm talking and writing at the same time, so let's make sure I didn't make a mistake. Okay, great. So this will be 3x plus 20 equals 5x plus 6. We're going to subtract 3x from both sides. So x will be 7. It's pretty easy. All right, for numbers 4, 5, 6, and 7, our goal, well, and really all of these other problems down here, we are going to be looking for the values of whatever's inside of our triangles or outside of our triangles. It just kind of depends. So the first thing that I'm going to do is I'm going to look at number 4, and I automatically see that angle 50 is vertical with y. So I know that y is going to be 50 degrees. I also know that over here I have a triangle, and so that bottom angle x is just part of that 180 degrees, so 180 minus 90 minus 50 will get me 40. So this angle down here, angle x, is going to be 40 degrees. And then the same thing can be true about angle z. It's inside of a triangle, so I can subtract 50 and 70 from that, from 180, and I get that z is 60 degrees. Looking at number 5, there's a couple different things that I could do here, but again, noticing right off the bat that I actually have a triangle that has two of its angles, so I can do 180 minus 22 minus 72, and I get that W is 86 degrees. Now that I know angle W, when I look at the right triangle that has y and x in it, I only have one of those angles, but in order for me to find one of them, I need two of them. So there's a couple things that I can do from here. I can either implement the remote interior angles that I just talked about a second ago, where I add these two angles together and set them equal to my exterior angle. That's one option. The other option I have is that these two angles right here are supplementary, which means that they add to give us 180. So I can do either. So I can do 22 plus 72 equals x, so that'll be 94. The other thing you could do is do 180 minus 86, and I'm going to double check because I don't trust myself. It's also going to give you 94. So no matter which way you choose to do this, you're going to get that angle x is 94 degrees. I'm going to go ahead and erase some of this. So we know that angle x is 94 degrees. And now that I know that that's 94 degrees, I have enough information to subtract from 180 minus 94 minus 30 to get me that y is 56, as long as I didn't make a mistake. All right. Looking at number 6, there's some things I can do here, but when I take a look at this, I automatically see that the remote interior angles can equal this exterior angle. So automatically x is going to be 70 degrees. If x is 70 degrees, I can say that these two angles are supplementary. They add to give me 180, so y would be 110 degrees. The other thing I could do is look at the top triangle, and I know that one angle is 30 and one angle is 40, which add to give me 70. And so in order for me to create a full triangle, that other angle would have to be 110, and that top 110 is vertical with the bottom 110. So either of those work. Now, this one also asks for the triangle type, which is just me classifying the triangle. So angle x is 70 degrees and angle y is 110 degrees. And then my angle type, I have one angle that is greater than 90, so it's definitely obtuse. And since all three of my angles, my 30, my 40, and my 110 are all different, that means that the sides will also be different. So we have an obtuse scalene triangle. And again, you can put scalene, obtuse, it doesn't matter. All right, taking a look at number 7. Number 7 is going to require us to do a system because we've got two unknown variables, which means that I need two equations. And there's a couple of ways that I can do this. I can actually end up making 3 different equations, but I'm going to pick the 2 that I see right off the bat. I know that 14x minus 4y plus 112 will equal 180 because they're supplementary. But then I can also say that these two remote interior angles should add together to get me 112. So 8x plus y plus 12x minus 3y equals 112. The other thing that I could do that I'm not going to do is I could add these 3 angles together and set them equal to 180 because there's 3 angles in a triangle, but I only need 2 equations. All right, so I'm going to do a little bit of rearranging here to get my 2 equations. This will be 20x minus 2y equals 112. Okay, so right now I have 14x minus 4y equals, whatever that is, 180 minus 112 is 68. And then we have 20x minus 2y equals 112. As a reminder, we're going to solve our systems using substitution. I'm going to make this bottom equation get multiplied by 2 so that I can cancel out my y's, but I need that this bottom y here to be a positive 4. So we have 14x minus 4y equals 68. I have negative 20x plus 4y equals 112 times negative 2 is negative 224. Those cancel. This will get me negative 6x equals negative 156. Divide that by negative 6, and I get that x is 26. And then y will be whatever it is whenever I plug x back in. So I'm going to take this x and I'm going to plug it into this top equation here. So we have 14 times 26 minus 4y equals 68. 14 times 26 is 364. Minus 4y equals 68. I'm going to subtract 364 on both sides. And I get negative 4y equals negative 296. I'm going to divide that by negative 4. And I get that y is 74. Neither x nor y are their own individual angles, so I don't need to put an angle degree or a degree symbol on there. I'm not going to do the rest of these in this video only because it's going to make this video really long and I don't want to do that. So you can always go check the completed notes key to see kind of what we did for these problems. And if you have any questions, you can always go see your teacher during their regularly scheduled tutorial times, and I will see you in the next video. Bye.